Hello everyone, welcome to Recitation 2 of CS 177. Today we will look at programming exercise 1-2 and lab 1-2. And instead of just solving it directly, we will walk through the full solution and get into the mindset of how to go about solving problems like this. All right, so let's get moving. So the first problem we will look at will be from programming exercise 1-2, which is this one. Over here, you are asked to review chapters 2 and 3 from the textbook. And then, having used what we just learned from those chapters, we will input 3 sides of a triangle and generate the area of the triangle as given using these equations. All right, so just like always, and which is always the best practice, we will first write the pseudocode, and after we write the pseudocode, everything will become clearer, and from there we will translate everything to Python. So without further ado, let's go ahead into idle and start coding. Okay, so I have an empty Python file opened up here. So before writing the actual code, let's first build up our workflow, the logic or the pseudocode in plain English instead of like codes. Okay, so what do we need from here? So initially we want to first print out the description of the program. Second, what we would want to do is we will take the user inputs, that is the 3 sides of the triangle, or more precisely, the length of the 3 sides of a triangle. Okay. Third, what we need is we need to calculate S. So we'll do calculate S. And almost there, we will calculate the area. And finally, we will output or print the result, which is our output. Okay. So first, let's print this out. Sorry about the typo. So we will print out the description of the program. Let's print that out. So let's do print. This program calculates the area of a given triangle. I think that should be fine for now. Now, what we need is we want to take the 3 user inputs, which are the 3 lengths of the 3 sides, which is A, B, and C. So let's do that. Let's do A equals eval, meaning we're going to translate anything that's given to the program into a number. So input. And then we want to have the appropriate input message, which is what is the length of side ABC. So what is the length of side A? So similarly, we will do this B. So let's get rid of that and change the A to B. At this point, since we are working together towards the final solution, I just realized that we missed something important, which is we do not have the whole code in any function. So something that might happen a lot, which is a good thing to demo, is that we missed the main function. So we need to define the main function here, right? So this whole code that we wrote should be inside the main function. And at the very end, we will print this out. We are going to call the main function. Okay, so the way we define it is def main, and everything inside of there would be indented. So it goes a little bit on the right. So now, again, just to recap, def main, we are printing out the description of the program. So we'll take the user inputs. So what's the length of side A? What's the length of side B? Now we want to calculate the length of side, take the length of side C. Okay, so we're actually done with the input taking from the user. Observe that the indentations are extremely important. Unless we indent things properly, the program will yell at us later. So now we need to calculate S. In order to calculate S, we have the equation given in our handbook, which is S equals A plus B plus C divided by 2. Let's go ahead and do that. S equals A plus B plus C divided by 2. So now S will have the value of A plus B plus C by 2. And then we can calculate the area. Let's just call it area equals. You see that we have S multiplied by S minus A multiplied by S minus B multiplied by S minus C. So, and there's a square root over it. Let's do the part without the square root first. So we want to do S multiplied by S minus A multiplied by S minus B multiplied by S minus C. All right. So one thing to note is when we look at the equation, we do not see the multiplication signs over here. However, Python doesn't understand these implicit multiplications that we humans understand, which is why it's always important to put in the multiplication symbols, meaning these asterisks or stars. But we are not done. We need to have a square root of this. And in order to do a square root of this, one way, I'm going to show you two ways. So one way is to take the whole thing and raise it to the power of half. So from basic mathematics, we know this, right? And then we can simply output the result as print the area of the triangle is area. Okay. I believe we're done. So let's go ahead and save it. Let's do let's be 1-2, and let's run it. Okay. So yelling at us, meaning we have a problem. So most likely what the problem is with some kind of a parenthesis issue. This kind of things will always pop up for us. So we see that there are 3 starting parentheses, but 2 ending ones. So let's fix that. It's good to have this happening live. So let's run the module, and here we go. It's a little bit of time. Again. Did we call the main function? See, we did not call the main function, which is why we are seeing nothing. So we need to call the main function. There you go. Now if we save it and run it, aha, that is more like it. So what is the length of side A? Let's give it 3, give it 4, give it 5. The area of the triangle is 6. Is that what we are expecting? Turns out yes. Okay, let's now go ahead and try a different method, which is of course a very similar method, but instead of raising it to the power of 0.5, we will use the square root function of the math library in order to import the function. What we write is import square root. However, we need to define from where this is coming from. So we write from math import square root. Okay. And instead of raising the power of this whole thing, what we can simply do is we can write sqrt and put the whole thing inside the function. Save it. Let's run this change. Again, let's do 3, 4, 5, and output is fine. Okay. Now let's try another test case. And let's do the second test case, which is 10, 5, and 6. So let's do 10, 5, and 6. So we have 11.399. And that's exactly what we are expecting. So good job. We are done with programming exercise 1-2. Now for the more interesting challenge, which is uh, the second thing that we are going to look at today. This is the lab 1-2. So for the lab, what we had was we wanted to figure out the approximation of the log of a given number inputted by the user. And we used this specific series of summations to figure out an approximation of the log x term. And the things that are going as inputs are the number that needs to be counted for the logarithm. And second, we wanted to have how many terms of the equation we want to be summed up. So the larger meaning more accurate. And then we want to print out the actual approximation. And finally, we want to output the the distance or the difference between the approximation and the actual value of that specific number, which is x in our case. So there are definitely some inherent challenges in this specific series, and this has come up quite a bit on Piazza. So let's actually discuss how to go about solving this problem. So one thing to do, and one thing we all encourage you guys to do, is read the whole question multiple times if it's a challenging one. And if you have read the handbook, you'll realize that the pseudocode for the program is actually given to you in the part 2 of lab 1-2, where the book tells you that what you should do, which is we should first define the main function, then we display the description, then initialize any necessary variables, prompt the user for the inputs, which are two inputs. One is the x value and one is the number of terms value. And then we set up a loop based on the number of terms determined by the user, so the number of terms. And then inside the loop, we iteratively, meaning step by step, we will figure out the terms one by one and add them up to a total. Finally, we will display the approximate logarithm for that number, and at the very end, we're going to display the difference. Okay, so this is the main workflow. We need to have this in the program. However, even before jumping ahead to that, we need to, let's revisit the mathematics part of the challenge. So since we will be writing a loop, the main idea, if we break this down, we'll realize that when we write the loop in every iteration of the loop, we want to get one term added or subtracted to the main summation. And if we look at the actual equation, we see that the first term is positive, it's a plus, then we have a minus, then a plus, then a minus. So this is inherently one of the main challenges that we have to deal with. So the way we will set this up is in the first iteration, we want to come up with this term, the very first term, which is x minus 1. In a way, we can write this as 1 by 1 into x minus 1. In the second iteration, we want to come up with the term 1 over 2 multiplied by x minus 1 squared. In the third iteration, we want to build up the term 1 over 3 multiplied by x minus 3 cubed, and so on and so forth. If you look at the pattern here, you'll realize that in every iteration, what's happening is that based on the value of I, we can actually adjust the terms that we are going to extract, meaning we can actually use this loop, the value of I, to generate the terms and then add them up to the final result. So let's go ahead and give it a whirl. All right, okay. So let me go ahead and close this. Let's have another file. First, as always, we are going to put in the pseudocode. And as you can see, the pseudocode is set up for us already at this point because I have copied over the pseudocode from the handbook, which is this part 2. So just to be more specific, let's read this along. We will first define the main function. Then we will initialize any necessary variables. Then we will prompt the user for the input values. After that, we will set up the loop based on the number of terms that the user gives. Then we will calculate an approximate logarithm of the term, which will come out to be the summation of the series. And finally, we will display the approximate logarithm of the number. In fact, at the very end, we also want to display the difference between the approximation and the actual log value. Okay, so now we are set up. So this is always the best practice, to have a plan like this, to have a workflow defined for us so that we know how to go about writing a program, all right? Okay, so now that we have this pseudocode, let's go ahead and follow along with the pseudocode. So let's define the main function. So let's do def main. Now that we have def main, and what's the next step? The next step is let's initialize any necessary variables. So the name of the variable that we can give it might be approx. Let's call approx equals 0. So initially this is 0, and we are going to add up the terms to this. So that's why I just assigned it to be 0. Now we will prompt the user to input some values. So the first one is the x value. So like before, we're going to take input as eval input. Please enter the number for which you want to approximate logarithm 4. That works. And the second user input would be the number of terms. So the number of terms, let's see, the output we want to show is how many terms. Okay, so let's call that n. N equals eval input please enter the number of terms. And that should give us the input part. So the input part is taken care of at this point. Now we want to set up a loop based on the number of terms determined by the user, okay? So let's start by writing a loop. Let's initially take baby steps into writing this loop, because this is the tricky part of the program. So let's write for I in range. Let's go, instead of starting from 1, instead of starting from 0, let's start from 1 and go up to n plus 1. So the reason I wrote n plus 1 instead of n, it is n plus 1 in this solution because we want to go up to n. Because if you have read through the documentation of for loops, You know that if you have a loop that goes, if we had written 1 comma n, it would go start with 1 and end at n minus 1. So if we want to end at n, actually n, then we should be going up to n plus 1. However, this program can be done with just range n also. We will look at that too. So we will actually solve this program in two separate ways. Okay, so let's just call this program uh, alternative 1. So this is like the, oh, no, let's call this version 1. Okay, sounds better. Okay, so now we have a loop for I in range 1 to n plus 1. Let's print out the value of I, and that's it. I mean, the program is not it, but just to give it a test run, let's save it as this and let's run it and see what comes out. Run module. Okay, so we want to enter the value of x first, so 1.5. Let's enter number of terms, which is 5. So you see that we are just printing 1, 2, 3, 4, 5. So we basically set up the loop and the loop works. These are like the small milestones that we want to go through until we reach the actual final product. Okay, so now one way to look at the problem, or one of the things that to solve initially, is to solve the alternating positive negative issue. So when we are dealing with term 1, we want it to be positive. When term 2, we want it to be negative. When I is 3, we want it to be positive again. When I is 4, we want it to be negative, right? Okay. So one way we can do this is, if you think about the number -1 and raise its power, you'll realize that -1 to the power of 1 is -1, right? -1 to the power 2 is +1. -1 to the power 3 is again -1. So -1 to the power 4 is going to be +1 again. So you see that as we change the powers of -1, there's an alternating pattern. So why don't we try this out? So because in this loop, the iterator or the counter is I. So the value of I is changing in every iteration, as we have just seen, that it goes from 1 to n. So where n was 5 in our last test run. So why don't we try out? Let's make a variable temp. Let's call it t to be -1 and raise it to the power of I. And then let's just print that. Let's not worry about the printing of I. So if we run this, so 1.5, 5, you see that the loop initially, when n equals 1, is giving us -1. When n equals 2, giving us +1. When n equals 3, it's -1 again. So we have this alternating pattern, but there's a problem. The problem is, let's print out something a little more specific. When I is I, t is this. Okay, so let's run this again. 1.5 and 5. So let's look at the behavior. When I is 1, t is minus 1. When I is 2, t is positive 1. When I is 3, t is negative 1. I is 4, it's 1. And 5 is minus 1. So when it's 1, it's negative 1. When it's 2, it's positive 1. So we actually want a little different. We want when I is 1, we want it to be positive. But what we have right now is when I is 1, whatever t is negative. So we just want to switch it up so that when I is 1, we get something positive. When I is 2, we get something negative. To achieve that, instead of raising it to the power of I, why not we will raise it to the power of I plus 1. So 1 becomes 2, 2 becomes 3, and so on and so forth. And things should be in order. So let's run this. Happened. Okay, there you go. 1.5, 5. So when I is 1, t is 1. When I is 2, t is minus 1. I is 3, it's positive 1. When I is 4, minus 1. I is 5, it's positive 1. Now we're cooking, right? So we have the signs down at this point. Now it's a matter of building up these terms. So let's call them the variable term. Let's not print this anymore. Let's call it term. Let's do term equals. So now that we already have this t thing, that's going to take care of our positive negative issue, we can just focus on the equation. So it should be 1 divided by 1 in this case, in our first iteration, multiplied by x minus 1 to the power 1. And only the denominator and the powers are changing. So let's go ahead and deal with that. Since these are the values of I in each iteration, simple to actually write it out. The term is equal to, let's do 1 over I, 1 over I, y, because of this 1 over 1, 1 over 2, 1 over 3, multiplied by x minus 1 raised to the power of, again, when it's 1, the power is 1. When it's 2, the power is 2. When it's 3, the power is 3, and so on and so forth. So it's basically I. And now the the fun thing is the fact that this is always going to be positive, the variable term. So we want it to alternate between positive and negative. The way we can do that is use this a variable t that we just made, which actually alternates. We've just seen how that works. So if we simply multiply it by t, it's going to be positive first, negative then in the second term, then positive again, and then negative in the next iteration. So moving forward, what we want to do is we want to accumulate these terms, all right? So where we're storing our approximation is here, which is called approx. So every time the loop runs, we want to do approx plus equals term. So meaning every time a term is determined, add it or subtract it, give depending on what the value of t is. So we actually now have the approximation of the term of log x down. So while after setting up the loop, we actually now have the logarithm of the approximation calculated. Now we're almost at the end of version 1. And to deal with this, let's just print this out. Let's do print the approximation of log x is approx. You need to be very careful about concatenating strings like this, because many a time we make mistakes doing this. Okay, so let's run it and let's see if we have. If we run this, let's try 1.5. Let's try 5. We see that we get the output 0.40729. Is that what we are looking for? Let's see. 0.40729. Yes, this is right, but we are getting a much larger value after the decimal point. The way we can solve this is by, instead of printing that, we can round this to 6 decimal places. So let's go ahead to that. And let's actually print out the full output. So the approximation of log x is, yep, that should do it. Let's run it. Okay, so 1.5 number of terms. Let's go with 5. Okay, now we have exactly the answer that we are looking for from the handbook. Okay, there's one more thing that needs to be done, and that is to display the difference between the approximation and the actual log value. And the way we can do this is, so we can simply print out the difference. However, in order to get the difference, we need the log function. To get the log function, we want to have from math import log. Okay, so now we have the actual logarithm function. And the way we can do this is print the difference between the approximation and the actual value is, well, this is not verbatim from the handout, but gets the point across, is, for we know that the approximation is in the variable approx. And to calculate the log of x, we just write log x. However, there's one small detail I'm missing out on, which is we need to round off this final output also. So in order to do that, let's do round, comma 6. And this should be done. So let's do 1.5. Let's do 5. That's exactly the answer that we were looking for, right? Okay. So now this was version 1. Version 1. Now let's do the same thing in a slightly different way, okay? Let me copy this whole thing over. Let's make a new file. Let's paste. I've pasted this. Now I'm gonna remove everything except for the comments, right? So everything is gone, gone, go away. Actually, we can reuse some of the things. For instance, we would still be using the same ideas like before, except this time we will do the loop or the alternating of the positive and negative a little differently. So we will define the main function that somehow went away. So let's do def main, initialize any necessary variables, just the same as before. So we can reuse this. Let me make this a little more manageable. So we can do this. Prompt the user for the input values. Still, we can use the same idea. Now, this is where the change is, okay? This is version 2. We will set up a loop. Like before, let's do for I in range 1 through n. And we will do the math here. However, last time we used the idea of raising the power of -1 to different numbers, right? So instead of doing that, let's introduce a new variable. Let's call it flip, and let's assign the value 1 to that. And what we are going to do here, just like in our previous version, where this variable t was alternating between 1 and -1, we are going to use the variable flip to alternate between positive and negative, so plus and -1. So instead of doing a -1 to the power of something, if we simply print the value of flip here inside the loop, and at the end of the loop, every time, if we do flip equal and assign flip multiplied by -1, do you realize what we just did? What we just did is initially flip was 1, it would be 1, and after whatever math we want to do here, it's going to be multiplied by -1. So next time flip is going to be -1. You see? So, and when it's -1, by the time it has done the math, it will be again multiplied by -1, turning the -1 into +1. So we basically have dealt with the alternating positive negative once again. So we can actually run this. Let's call it lab2-1 v2 version 2, and let's run it. And the only print statement is this one. So we want to see if flip is working correctly or not. Let's do run module. Sorry. Okay. So 1.5. Let's do 5. You see that it's 1 minus 1, 1 minus 1. So one thing though, this we have 4 values, but we were expecting 5. Why is that? Why are there 4 values instead of 5? Because we didn't deal with the n thing, because it's gonna go up from 1 to n minus 1. So to deal with that, we just make it n plus 1, and we can let's just put something descriptive there. Flip is just run it. 1.5, 5. Now we got it. Okay. So just like before, now that we have dealt with the positive negative with something, we will build up the terms. Let's build the term like before. Let's do term equals 1 over I. Actually, you know what? We can reuse our previous version here, which is this one. So instead of t, we can use the word flip. So term is 1 over I multiplied by x minus 1 raised to the power I multiplied by t. However, there is no t in this version. It's going to be flip. Because flip is the variable that switches between positive 1 and negative 1. And then approx is the accumulation of the terms, and flip is the alternation variable for us. And we actually have the calculation of the logarithm done here. Now, just like before, we can print this out. We have already done this there. Okay, so let's do print the approximation of log x is approx. Okay, let's run it and just just test it out to see if it's working or not. It's always good to check. So 1.5, let's do 5. Oh, we have a print inside the loop there, which is why we have like all these numbers. But at the very end, we are actually getting the right answer. So let's see, why do we have so many printouts? Why do we have like 5 of them? Because this print statement turns out to be indented inside the for loop, which it should not be. So let's take this out here. So now this is in the same level as the main function, like inside the main function. So let's run it again. Let's do 1.5. Let's do 5. All right, now we're good. However, we need to round it again. Let's do round. approximation 6. And similarly, we want the difference of the approximations, for which let's just do it from scratch. Print the difference between the approximation and actual log value is x approx. However, here's one thing: we have not imported log, or have we? Okay, we have. So you need this in order to use the log x function. The approx minus log x, and let's round this to 6 decimal points, comma 6, slope this, and that should do it for us. So 1.55. All right, and there we go. So we are actually done doing this. So if you have any more questions, or if you want to run your solution by us at this point for this program, then you can get a hold of us anytime. We're always on Piazza or email. And one thing to note is there are absolutely many, many ways of doing this, the same problem in different ways. For instance, let me just, before ending, instead of doing the one going from 1 to n plus 1, now we're going from 0 to n, all right? So, okay, instead of doing it here, I think it's more convenient to, or makes more sense to do it here. So this is version 1. It's where we use the -1's power. So instead of going from the in the loop going from 1 to n plus 1, if you wanted to go from 0 to n, that's fine also. So except this time, when you are making the terms, you cannot have divide by 0. What you need is to have a I plus 1 instead of all the i's. So there. And since -1 was raised to the power of I plus 1, this time you can just forget the I, forget the 1. So now, if you run this, you can do 1.5, 5, and we still get this same result. So basically, what I'm trying to get at is there are so many ways of doing the same problem, and there are other ways like using conditionals, but we haven't covered conditionals yet. So I just showed you 2 distinct ways of doing this specific problem. And I really encourage you guys to write pseudocodes and know to first formulate the question properly and then go about writing the code. Meaning, first have the logic down, the math down, and then the code is just gonna flow. It's gonna become simple. All right. So with that said, I wanna thank you for today. Thank you very much. See you soon.